All right, welcome to day 8 of AP exam review. For homework, you'll be doing the calculator portion of the pink packet, the 2023 multiple choice, and then you'll be doing 5 and 6 in the free response on a separate sheet of paper for the 2023 exam. Those will be no calculator. We'll pause the video for maybe 90 seconds to 2 minutes. We'll do 2 minutes for you to check each of your multiple choice answers. And then because I won't know which ones you want to go over, we're just going to go through them all. So for the first one, we're given arc length. This is not a parametric, it's just a regular equation. Our setup is the integral, square root, derivatives squared plus 1. So we want to know which of the following could be a function for the curve. Well, if our derivative squared is 9x to the fourth, that means our derivative must have either been 3x squared or negative 3x squared. So one way you could do it is just look at the choices and based on the derivative, see which ones could give you either 3x squared or negative 3x squared. That eliminates choice A and E. From there, the 0.16 had to be on the curve. So therefore, you can just fill in the 1 and the 6 and see which gives you back a true statement, and that's choice B. Now, if you wanted to do it non-multiple choice method, you could have done your antiderivative. Again, it could have been positive or negative 3x squared for the derivative, so we get plus or minus x cubed plus c. Stub the 1, 6 in, you get two different possible c's, and then just see which one of those is a choice, and that top one there matched with B. For 16, our tangent line is passing through those points. So the tangent line slope, f prime of 1, should match the slope between those 2 points. So do change in y over change in x, you get 3, which is choice C. Over on the next one, do your dy dt over dx dt, you get 3t squared over 2t minus 4. But we don't know what the t value is. So put negative 3 in for x and 8 in for y. And we're looking for the value of t that is then a solution of both those equations. Well, the 8 equals t cubed, there's only one solution. It's t equals 2. So because there's only one solution, we don't even have to bother solving the other one. That must be the value of t. When you put that in for t, you get a undefined slope, meaning we have a vertical tangent line. Vertical lines have the equation x equals something. The x value of our point we are going through is negative 3, so x equals negative 3. In 18, we had a chain rule that we had to do. Derivative of an integral that goes from a number to an algebraic expression. Our algebraic expression gets subbed in, and then we multiply by the derivative of what we subbed in afterwards. So we're going to have f of 2x, then times the derivative of 2x, which is 2. We wanted to do g prime of 3, so replace the x with 3. We now have f of 6 times 2. F of 6, look at your graph, find what the value is. Now, this graph, it doesn't look like it's exactly negative 1. It really looks like it's like negative 0.9 or something. But if you have negative 0.9 times the 2, that would give you negative 1.8. So the best choice that we have there is choice C, the negative 2. So our slope is 2x plus 3. That means dy dx is 2x plus 3. So do the antiderivative and then sub in your point of 1, 2 to solve for c, and you get the equation x squared plus 3x minus 2. In our series there, we want to recognize that we are always positive. We've got all the factorials, and the powers don't match, but there's no powers missing once we start going. So we want to think about which of our common ones had all the terms, all positive, and all the factorials, and that was e to the x. Well, notice all of our powers are 2 more than the factorial. So that means our e to the x must have gotten multiplied by x squared. So if we do that, that would give us terms of x squared plus x cubed plus x to the fourth over 2 factorial plus x to the fifth over 3 factorial. Well, we want our thing to start off right there, meaning we want to get rid of the x squared and x cubed, so we have to subtract those two off. That's why it's choice D. For 21, this is almost in our form that we like for logistic differential equations, except we want just m to be subtracted. So you got to pull out a 1 over 200. Then that gives us the carrying capacity spot is 200. So our limit as t goes to infinity of m will just be our carrying capacity, which is 200. In our next one, imagine this summation was an n on top and it was like n to the fourth plus 1. We would do a limit comparison test of 1 over n cubed because our gap between the powers is 3. You'll notice that gap between the powers, because the numerator power is 1, is just 1 less than the denominator power. So if we have n over n to the p plus 1, we'd want to do limit comparison with 1 over n to the p minus 1. Well, for a p series to converge, we need the power to be greater than 1, so let p minus 1 be greater than 1. Add the 2 over, or add the 1 over and get p is greater than 2, so it's choice E. For 23, this is an integration by parts with Lipit. We don't have any logs or inverse trig, so let u equal the x. The dv is sine of 6x. We do have a little correction of 1/6 when we do our antiderivative of the sine 6x. Sine's antiderivative is a negative cos. My negative is up there a little bit above the 1 on the 1/6. So then do your uv. When you do minus integral of v du, I pulled out my minus 1/6 to make it a plus 1/6 in front of the integral. Do another correction by 1/6 because it's technically a u substitution. And don't forget your plus c on the end. We get choice B. In 24, sine, the biggest the numerator could be if you have a sine is 1. So we know that sine 2 over pi has to be less than 1 because it's something at most 1 over 3.14. So that's a geometric with absolute value of r guaranteed to be less than 1. So that's converging. So 1 will converge, and we're looking for diverges. 2, we got a p series with p greater than 0, less than or equal to 1, so that's a diverge. And as n goes to infinity in choice 3, that plus 1 is not doing anything. So you have essentially e to the n over e to the n. So those terms will approach 1. Because the terms are not approaching 0 when n goes to infinity, that diverges by the nth term test. So choice D, which was options 2 and 3. We want to do a right-hand Riemann sum. Gap between the x's is 3. Right-hand y value is 28. Then for our next base times height, the gap between the x's is 5. Right-hand y value is 34. And between the 10 and the 14, the gap is 4. Right-hand y value is 30. Do that all out, you end up getting choice D. 26, we have a partial fractions. After initially, you'll do 2x over x plus 2 times x plus 1 equals a over, I did x plus 2 plus b over x plus 1. Multiply everything by that common denominator, and then that gives you this line here. Pick strategic values of x to let it equal. So I let x equal -1, eventually get b is -2. I let x equal -2, eventually get a is 4. So write your separate fractions. These are technically u substitutions, but when u is equal to x plus 1, there will end up being no correction. So it ends up just being 4 natural log absolute value x plus 2. Then you got a -2 natural log absolute value x plus 1 with your plus c, so choice D. In 27, we're doing the derivative of an integral that goes from a number to an algebraic expression. We've seen this probably at least 10 times now. We've mentioned it in review. So your algebraic expression gets subbed in for t, and then multiply afterwards by the derivative of what you sub in. So choice E. Your second degree coefficient should be the second derivative over 2 factorial. So you've got to do a couple derivatives. So I thought of it as 1 plus x to the -2. I did my derivative. There's technically a times 1 there by chain rule, but it's not doing anything. And then I did that next derivative, which again technically has a times 1. We are about x equals 0, so this is really a Maclaurin. Sub in 0 for x. And we get our second derivative at 0 is 6. So that's the numerator of your second degree coefficient over 2 factorial. So we just get 3, which is choice D. Going over to our free response, start at 0, 5, follow your slopes, and it should level off at about that value that looks like it's 35, 40, somewhere in that neighborhood. For part B, we want a tangent line equation. Well, 0, 5 was our point. Take your dm dt that they told you, sub in 5, and you get 35 force for the slope. So we have m minus 5 equals 35 force times t minus 0. We wanted to now use that to approximate at t equals 2. So put in 2 for t and neaten it up. And I did mine in decimal form, 22.5. You could have also had 45 over 2, and that was degrees Celsius. Next, we want an expression for the second derivative. Well, that original thing I distributed the through the parenthesis. 10's derivative is 0. Negative 1/4 m would just be negative 1/4 and then dm dt. They said we wanted that second derivative in terms of m, so we got to replace dm dt with the 1/4 40 minus m. So we end up getting negative 1/16 40 minus m. We want to know whether our estimate from the previous part is an over under estimate. So our goal is to figure out concavity. So sub in the 5 because that was your m at the point of tangency. We get a negative back. So because second derivative is less than 0, m equals 5. Our graph is concave down, meaning the tangent line is an over estimate. We've seen recently in class one like this. We want separation of variables. So get your m stuff on the left, get your t stuff on the right, do your antiderivative and sub in your point. So I divided the m 40 minus m over. I multiplied the dt over. We technically have a u substitution on the left there where u is equal to 40 minus m. So du equals minus 1 dm. So we have a correction of negative 1 to get dm by itself. And then that would become a 1 over u, whose antiderivative is natural log absolute value of u. So that's where the negative natural log absolute value of 40 minus m is coming from. Right-hand antiderivative is pretty straightforward. Sub in your 5 for m to get c, which is negative natural log of 35. We resolve our absolute value by the initial condition. We had a value of 5 that makes the inside be positive. So now we just write the natural log with parentheses and 40 minus m. If the inside had been negative, it would have become negative 40 plus m. Divide the negative 1 over, switch your log to an exponential. I then subtracted the 40 over and then divided by negative 1. Now, I just left everything in the exponent. You could have also had it come out front as well from that natural log of 35. I would suggest on a free response, don't do more simplifying than you need to. You're just risking a potential chance for an error. If you had brought it out front, you would have had negative 35 e to the minus 1/4 t and then the plus 40 on the end. And going to number 4, relative min, max, or neither at x equals 6. Well, it's the graph of f prime at 6. It is positive on the left, derivatives positive on the right. There was no change in sign, so this is a neither. And just talk about how f prime didn't switch signs. Next, we want to know concave down. That's when the first derivative has a negative slope. Or in other words, as I said, they're decreasing. So that was the interval negative 2 to 0 and 4 to 6. As we go to C, we'll do direct substitution, subbing in R2. All of them are pretty straightforward except for the f of 2. So f of 2, though, they told us in the question was 1. So now replace f of 2 with 1, and we get a L'Hopital's case. Go ahead, take your derivative. We'll sub in 2 again. Really, the main one to think about is that f prime of 2 that we're going to do. That's our slope at 2. Notice that we are just going Uh, notice that our graph of f prime when x is equal to has a value of 0. Simplify it, you end up getting 3. And for 4D, we want the absolute min, so we've got to check the relative min and the endpoints. In the graph of f prime, it is f prime is switching from negative to positive at x equals 2. So we're going to check in an accumulation function, negative 2 to an 8. The value they gave us in the problem, that f was equal to 1 when x was equal to 2. So all of them should have 1s out front and 2 on the bottom. Then do your integral from 2 to negative 2. We would want to flip our bounds and put a negative out front, so then we can just do the area from negative 2 to 2, which is 1 minus 3. Subtract that from the 1 and you get 3. F of 2, they just told us was equal to 1, or you can think of it as it's 1 plus the integral from 2 to 2. And then for 8, we'll have 1 plus the integral from 2 to 8. So if we do our areas, starting at 2, we have this triangle, and then we have this square that we have to subtract off the half circle to get the area underneath. And that's where we're getting the 11 minus 2 pi eventually. For those 3 y values, we're just looking at which one is the smallest. 2 pi is a little bit bigger than 6, so when we subtract that from 11, we'll be a little less than 5. So it's still not going to be small enough to be less than the 1. So we have an absolute min of 1. For the remainder of the period, you're going to start working on your next homework. So 2023, free response 5 and 6, those are no calculator, should be done in your notebook, or you can work on the pink packet and the calculator multiple choice questions. Have a great rest of your day.